Okay, welcome everybody. Um, we will go ahead and get started. It's close enough to 4 right now. We're recording this, we'll post it. If you've been looking at the GitHub repo, you noticed that I posted project 1. It's out. I'll put a note on Blackboard about this as well as soon as I get a chance. We're asking that you submit a design document by next Wednesday, the 28th. So you have a week on that one. And the project itself is due on the following Monday, the 2nd of November, the day before the election, in other words. What we're going to talk about in lecture today is really important, a little bit for the homework 5 if you haven't finished it, but especially for the project. You're going to be doing things in the project that are extremely similar to today's lecture, so I want to make sure I get through the lecture and explain everything. So we're going to talk about the lecture first, and then I want to save 15-20 minutes at the end to talk about project 1 and hopefully clarify any questions and let you get a good start on it. And then, as always, a warning right now, expect the second exam to be on Veterans Day, November the 11th, 3 weeks from today. It'll cover all the material so far and a couple of more things. And then we'll move on. So today's topics are a little bit more on file I/O. And also, we're going to get into multidimensional, specifically two-dimensional lists. Now, minor administrative note, I posted on Blackboard, so hopefully you all saw it. I did post updated code from Monday's lecture with the fix to the error, the thing I was trying to do on the fly at the end of the lecture. The problem was square brackets versus parentheses. I was trying to use append. I was appending an item to a list. And when I was using append, I was saying to append square brackets, not append with the parentheses. And so that messed everything up, which is what I get for trying to do it on the fly. But the actual code that worked out the full example to let you read from and then write back to the same file and make the changes of swapping dog for cat, that code is out there, and we'll talk about that if you have any questions. But as I said, I kind of wanted to move ahead today to the new material. So, lists of lists. Now, we've talked about lists so far that are of simple types. We have a list of integers. You can have a list A has the integer values 1, 2, 3, 4. You can have a list of floats, which are just floating point numbers. You can have a list of strings. The former Detroit Tigers pitching rotation, Justin Verlander, Max Scherzer, Anibal Sanchez, and David Price. That was the year the Orioles knocked the Tigers out of the playoffs a few years ago. List of strings. Or a list of Booleans. You can have an arbitrary list of true, false, true, true, and there's no parentheses around these. So these are Booleans rather than strings. So you can have these lists of simple variables, but it would be really nice if we can have a list of lists. And it turns out that in Python, you certainly can. A list, each of whose elements is also a list, is a two-dimensional list. You can move on to higher dimensions, 3, 4, etc. Let's talk a little bit about next week. But today, we're going to talk about two-dimensional lists. Two-dimensional lists are just lists, each of whose element is itself a list. And this is useful for representing something like this. This seems like forever ago, but this is a representation of the medal table from last year, just last year, believe it or not, World Track and Field Championships. IAAF stands for the International Amateur Athletics Federation, which is the body that governs international track and field in the Olympics and the World Championships. And this is the results of last year's World Championships. The U.S. won 14 golds, 11 silvers, and 4 bronzes for a total of 29. Kenya came in second with 5 golds, 2 silvers, and 4 bronzes for 11. Then Jamaica, and so on. This is basically copied from this particular website, which is not relevant. You can Google it if you want. Basically, I took this medal table from this website and copied it and put a screenshot of the first 7 countries on this page. And then later on, we're going to talk about doing that as a file. So what I want to do is I want to create a table, a 2D matrix. If you're familiar with linear algebra, a two-dimensional table. In Python, that's referred to as a list of lists or a 2D list. And the way we do that is, if you've taken linear algebra or something similar, you've learned the term row major order. Okay, rows always come first. Python stores two-dimensional lists, two-dimensional tables, as a row first and then a column within the row. And that plays into what you can do with the data values. It's easier to work by row than by column. We'll have some illustrations of that. Python is in row major order. Every row is itself going to be a list. Rank, gold medals 1, silver medals 1, bronze medals 1, and total medals 1. I don't have countries yet, but I will insert countries in and show you how we can do some manipulation. For now, we're going to leave country name out. So we create a list where each element is one of these lists. And specifically, we do it by this. Now, I'm going to copy this definition into PyChart. Okay. And this is our medal table, which is a 2D list. Let me get a new file up here in PyCharm, which will be October 26th, coding.py, so I can put that on GitHub when we're done. Here is the list of lists, the two-dimensional tape, the two-dimensional list. Okay, and if we come down into a console, we can simply load that in, and we see that it's there. And we see that medal table has this value. Now, the way Python displays this by default, it's hard to read, so we'll talk about it up here in my definition in the code section of this of PyChart. What I have done is I have created a list. The list representing the United States, rank 1, gold medals 1 was 14, silver medals 1 was 11, bronze medals 1 was 4, and total medals 1 was 29. This list shows the United States results at the World Track and Field Championships. This next list, the next row in my table, shows the results for Kenya. Kenya was ranked number 2. By the way they do it, the Track and Field Federation ranks you by most goals, not most totals, which is why Kenya is ahead of Jamaica. Kenya finished 2nd. They had 5 golds, 2 silvers, 4 bronzes, and they won a total of 11 medals. Jamaica finished 3rd. Jamaica had 3 golds. Jamaica had 5 silvers. Jamaica had 4 bronzes, and therefore Jamaica had a total of 12 medals. And then I went on for the rest of the top 7 entries. Okay. Now, when I want to refer to these things, remember this is a list, so I can refer to items, rows, and columns. Columns are going to be a pain in the neck because it's row major order. But if I want to refer to a row in this medal table, and we'll go back to the slides in a minute, I simply say variable name, sub, and let's go 0. As with all other lists, the first subscript, the first index is always 0. So in a 2D list, we start with row 0. Medal table sub 0 is this row. So when you have a 2D list, two-dimensional list, and you just give one subscript, you are asking for the row. You are asking what is in row 0. How do you ask for what's in column 0? Well, that's a pain in the neck. We're going to have to get there later. Okay, it's row major order. Anything with a row is easy. So medal table sub 0 is the United States. Medal table sub 1 is Kenya. And you get that results. Each row, as we've said, is a list. That means each element, each member of medal table is itself a list. So if you want to access a row in a 2D list, you just give one subscript with its row number. Row number, that's the one subscript, and away you go. If you want to access a single individual element in the medal table, you must give a row number and a column number, and row number comes first. So medal table sub 0 sub 2. This element, this gives me a single element in my two-dimensional table. Go to row 0, go to column 2. This is, by the way, almost always a question on test 2 in this class, or at least this is in both semesters I've taught it so far. This was a question on test number 2. Which comes first if you have a two-dimensional list, the row or the column? The answer is always the row is first, the column is second. So what is 02? That is 11. That is the number of silver medals won by the United States. By contrast, if I say medal table sub 2 sub 0, that gives the value 3. That is the rank, third place of Jamaica. That is the 0th element, the first element that we see, but it has index 0, in row 2, which is the 3, signifying that Jamaica was in third place. Okay, so index, the subscripts, always row first, always column second, and always the row and column are in separate square brackets. A common programming mistake if you've programmed in other languages, or if you're just used to math, right? If you're used to dealing with linear algebra and identifying an element in a 2D matrix, in a 2D array in math, you might try to do something like this, right? Sub 2 sub 0. Okay. That turns out in Python to be invalid. Okay, because the error message tells you the indices have to be an integer or a slice, not a tuple. That says you have to put a single value for what Python defines as a single value inside these square brackets. Okay, so that is our table. That is how it's defined. It's a list, each of whose elements are list. It is in row major order. The rows come at the highest level, then the columns within the rows. If you give a single subscript, it's how many rows or what row number you're talking about. If you give both subscript, it's row first, then column. If you say, I mean, this is a list, right? We have a length function. Length can tell us how long a list is. If you say length of medal table, it's going to tell you 7. Well, let's think about this. 1, 2, 3, 4, 5, 6, 7. Hey, that's the number of rows. 1, 2, 3, 4, 5. The way I've set it up, there are exactly 5 elements in each row. 5 columns. So clearly then it looks like that the length function of a two-dimensional list returns the number of rows. And that is in fact what it does. The length function always returns the number of rows. So if I say the length of the medal table, it comes back with here's how many rows there are. If I want to know how many columns are in my table, then I have to say something like this. Length of metal table sub 0. That tells me how many elements are in this row. That tells me how many columns are in my 2D list. So if I want to know how many columns, I have to say, what's the length of an individual row? Now, subscripts. Again, we always start at 0. The first row is 0. The first column is 0. The last row is always length. And if I use the dash, it would be an error. This, the length minus 1, is always the last row. Okay. And remember, just as with strings, just as with one-dimensional lists, I can shorthand and just say minus 1. The last row is minus 1, and I can count backwards. And you see that minus 1 and length minus 1 are the same thing. But again, if I'm talking about the whole two-dimensional table, the two-dimensional list, then this is the number of rows, and this is going to give me a row. If I want to do a column, then I'm going to have to say something like this. Metal table sub 0, row 0, sub minus 1. This gives me the last entry in this row. Okay, this gives me the last entry in this row if I say 0 minus 1. Okay, now, if I want the last element of every row, then I can write a loop. For I in range length of metal table, remember, this is how many rows, print metal table sub I sub minus 1. This code, if I haven't made a mistake, should print out for me the last item of each row. This should give me the last column. And in fact, it did. It actually worked, and you can see this gave me 29, 11, 12, 9, 8, 5, 6. So this is how you do a column. Okay, obviously, if you don't want the last column, you don't say minus 1. You can have 0. You can have 1. You can have anything. If you want to print out a column in a two-dimensional list in Python, you're going to have to use a loop. You cannot address an entire column with a single statement, a single subscript like you can a row. It's just a function of row major order versus column major order. You have to deal with the rows first. If you want to print out the columns, you have to use this loop and go through and print out the appropriate item in each column. Okay, so let's go back to the slides. Some notes. Right now, in this example, I'm going to have each row with the same number of elements and all the same type. That is not required. That was just the way I created this matrix. That was the way I created this two-dimensional list. I picked all integers. I typed them all in as integers. I made sure that no values were missing. I made sure that every row was the same length, 5 elements long, and all my elements were integers. They don't have to be the same number of elements, and they can be of different type. We could have inserted the name of the country, Kenya, in the second row, and it would be legal, but my note is, please don't do that unless you really, really understand what and why you're doing. You're going to run into problems if you start having different length elements in your 2D list. and some of them have different type values and others don't. So you can do it, and we will do it at everything. I'm sorry. Okay, one of my students is not seeing the screen. Is anybody seeing the screen right now? Okay. Okay, most of you are seeing it. Thank you. Okay, so Meseret, I apologize if I mispronounce your name. With a name like mine, I'm sensitive to pronunciation. Why don't you try to drop off and rejoin the meeting and see if that helps? I'm not sure otherwise how to. If that doesn't work, then I'll unshare and reshare. But why don't you give that a try since you appear to be the only one having the problem? Okay, thank you. All right. So bottom line, I set this up. I can have some freedom to change things if I wanted to. Now, again, this is what I just said. Treat this as a table or matrix. Rows are the outer elements, columns are inside. You start at 0. Length tells you how many rows are in the list. So metal table is this list. Metal table 3-2 is the element 3, the number of silvers owned by China. Now, the next thing is when you're dealing with a table like this is when constants can really help. Okay, constants can really help. We know that because of the way we set this up. We know that the first column is the rank. The second column is the number of golds. The third column is the number of silvers. The fourth column is the number of bronzes. And the fifth column is the number of totals. So what I'm going to do is I'm going to go up and I'm going to define constants for that. I'm going to say rank, and I use all caps because this is what we do for constants, equals 0. Column 0 is rank. Golds equal 1. Silvers is column 2. Bronzes is column 3. And total metals is column 4. Now, if I want to access something, for I in range, print metal table, I'm going to say, I'll copy the code so I don't lose this. I'm going to say subtotal. Now, did I say totals or total? Total. I said singular. Okay. Now, when I say this, and I execute it down here in my console, oh, I didn't run my constants. Okay, there we go. Let's run my constants in the console. Now let's run this. And now we see this works the same way. Okay, so we get the same results here. So constants are really useful at explaining when you're reviewing your code what everything is. This tells me column 0 is the rank, column 1 equals golds, column 2 equals silvers, column 3 equals bronzes, and column 4 is total. Okay, let's go back to the slides. I give an example here. Metal table sub 3 sub silvers tells how many. Sorry, let me kill the App Store. I accidentally cut that one. Okay, back to the slide. Sorry about that. Metal table 3 sub silvers tells us how many silver medals the fourth place country won. That would be, I believe, China. Okay. There's another reason for using constants, which is if you have to change values. I have a slide before that right now. Okay. So how many gold medals did the top 7 countries win total? Well, here's the loop. All I'm doing here is initializing total golds 1 to 0. Now I'm running a loop for I in the range, the length of metal table. Remember, this code is going to go through the rows. This code is going to go through the rows, and it's going to go through the golds column in each row and add those up to the total. And so when I'm done, golds 1 is going to be the total gold medals won by the top 7 countries in the International Track and Field Championships. Now, yeah, I didn't have to use the constant golds. I could have remembered that that's column 1 and said I won, but it's easier if I just say it's column 1. And when I run this code, we see that the top 7 countries in the track and field championships won a total of 31 gold medals. Nice to know I still got the same answer. Okay. Now, warning, you are allowed to have different rows, different numbers of elements at different rows. That is legit. And there are some legitimate reasons why you'd want that. But if you do that, this is a column operation. This is adding up all the elements in a column. Adding up the elements in a comma can become meaningless if you have different elements. If a column doesn't have the same meaning all the way down through every row, you can get into a problem. Okay. So, but if you know what your data looks like and you know what your table looks like, then this is how you add up everything in a column. Okay. Make sure, again, you understand what the table's doing. In our case, here is how we did the gold. Here is how we did, wait a minute, what did I do? Okay. Here, okay, this is what I was doing earlier. This is why this fails. Here, I said column 1 in element 2. I'm starting to put the country names in, but I haven't put all the country names in. So in one row, in row 1, the second place team, I added Kenya as the country. Okay, so now row 1, column 1 is the string Kenya, the country name. So as a result, if I take the same loop I just wrote, this is the identical code that just ran and told us there were 31 golds, total 1. This is now going to fail because at this point, this is not the number of golds won, it's the name of a country, and that's not an integer. And so Python will say, I can't add a string, and this will fail. Okay. If I try to add everything in column 2 to get the total number of silvers won, well, I get 11, I get 5, I get 5, I get 3. If I do that, my Python code will run. There's not a syntax error. It's all fine. But it's going to give me the wrong answer because in column 2, row 1, that's not the number of silvers Kenya won. That's the number of golds. So when you have this additional element in one entry and one row is different, all of a sudden any operation on a column becomes risky. It might not work, or you might think it works, but it gives you the wrong answer. So understand when you're doing this two-dimensional list thing, whether you're allowed to do columns or not. Now, it turns out that when I give you project 1, and we'll talk about this when I give you the data files, all the rows are identical. All the rows have the proper structure, except for a couple of things you have to get rid of. So you will be able to do these column operations in project 1 by using these rows, okay, because you'll be able to work on this 2D list. Now, I, in this case, simply created the 2D list by typing all the values in. I don't have to. Here is a case where I'm going to create a two-dimensional table that has all of the successive squares. Okay, so let me copy this code, and we'll execute it in PyChart and walk through it. Okay, make sure we don't have any syntax errors copied over. I don't believe so. Here's what's going to happen. I want a table, a 2D list with 5 rows, 10 columns. When you initialize a 2D list, and this is something I should have told you, when you initialize a blank 2D list, you only have a single set of square brackets. Okay. You can say square table equals this, and that is a valid initialization. Boy, I'm having trouble speaking today. That is a valid initialization of a two-dimensional table. You might think that you should do something like this, but it turns out that is not legal Python. And so this basically will hang on me and not do anything. So a note, when you initialize a blank two-dimensional list, a blank two-dimensional table in Python, you do it with a single set of square brackets. Okay, so that was a point I probably should have made earlier. All right. Now, in this case, I'm going to go through and create the numbers squared. I'm going to do this with nested for loops. So again, since Python handles things in row major order, it strikes me that the natural way to write this code is in row major order. Handle rows in the outer for loop and handle columns in the inner for loop. Now, what I'm going to have to do is use the append function carefully. If you try to append to a 2D list and just use the list name, it thinks you want to append a row. So in other words, let's say square table. Now I've initialized a 2D list. Okay. And now I say square table sub 0. Let's just create something like that is 1, 2, 3, 4, 5. Okay, it doesn't know that I wanted a 2D list yet. That's why. Let me get to that. Okay. All right. You can't directly assign this. You have to do the do the appending, and the appending puts in the whole row. And that's how you build it. You append the row. So let me work through the actual code I'm running, and then I'll explain it. What I'm doing here is I'm building a one-dimensional list. Row is going to be a one-dimensional list built by appending my number to be squared one at a time. So row 1, I start at 1. Row 1 is going to be 1 squared, which is 1. Then it's going to be 2 squared, because I'm going to add 1, which is 4. Then it's going to be 3 squared, which is 9. 4 squared, which is 16, and 5 squared, which is 25. And then I go all the way out to columns. Columns is 10, so the last value here is going to be 10. Num to be squared is going to be 10. The last value in this first row is 100. Then, when I have built this row, I am going to append that entire row to my table all at once. Okay, let me run this whole set of code, and then I'll go back and run it bit by bit to show you more what's happening. Also, it lets me check to make sure I don't have any bugs in here that I didn't catch when I ran it beforehand. Okay, this is what this code does. It produces a list. Here is the first row, 1 squared through 10 squared, 1 through 100. Here is the second row, 11 squared through 20 squared. 11 squared is 121, 20 squared is 400. Here is the third row, 21 squared through 30 squared. Here is the fourth row, 31 squared through 40 squared. And here is the fifth and final row, 41 squared through 50 squared. Now, this is hard to see. So one thing I'm going to do is I'm going to print, I'm going to put in a loop for printing, I'm going to print this a row at a time. So what I'm going to do is print the row. So you can see that the row is being printed on a separate line as it's being built. So the difference between this loop and that loop is I built this row, I appended the row to square table, and I printed it. This print statement caused this to be printed. Then the second time through the loop, that same print statement, this one right here, caused this to be printed. So you can see that I built a row. I built this row one element at a time by appending the next number squared. And then when I had the row, I appended the whole row to the two-dimensional list. And then I had each of my elements, and then I can still print out the square table. I could have put this print statement, rather than print the entire 2D list, I could have printed out a row at a time, and you may need to do that in Project 3. That's just a fairly straightforward print statement, for loop print statement. It says print out one row at a time rather than the whole matrix at a time. That's fine. Depends on what you need, whatever's clear. Okay. So this is building a 2D list, a 2D matrix in Python from scratch. Key things to remember: you initialize with a single set of square brackets. If you try to put in two square brackets, it'll fail. That's not valid Python. It means something else, actually. And the way you do this, the way you make it work, is you build a whole row and then you append the row. And just like we showed earlier, it's very difficult to append a column. You can't actually append a column. You can write a routine that will insert a column, and we're going to do that, I believe, in a minute. I believe I've got a couple of slides on how to do that. Okay, so that's how you add a row. How you add a row: you can insert a row in a specific place, or you can append a row to the end, just like you do with a 1D list. Columns, you can't do that. This is just what I was talking about into how to print it out, make your output look nice. Here's the slide I was looking for. How do you add a column to the 2D list? Okay, I have my 2D list, which is a metal table, which is not real useful. I've done this work enough to remember that the country that finished first is the United States. The country that finished second is Kenya. Jamaica was third. China was fourth, Ethiopia fifth, Great Britain and Northern Ireland sixth, and Germany seventh. What I need to do, I want to replicate the table. Let's go back to this website. Let's go back to the website where I got the table from. And you can see that the country name comes between rank and number of golds. So I want to replicate that. I want to insert the country name in between the rank and the number of golds. Okay. There's a number of different ways to do that. The easiest thing is this. I'm going to create a list. Okay. And the list is the same length as my number of rows. There's 7 entries, 7 rows. There's 7 entries in my list. These are the values to be inserted in the matrix as a column. I'm going to insert these values as a column, so I start by making them a single list. United States, Kenya, Jamaica, China, Ethiopia, Great Britain, and Germany. Now, what am I going to do? I'm going to go into my table. And in each row, this for I in range lets me do this by row. In each row, I'm going to insert into column 1, the second column. We always start with 0, so the second column is column 1. The ith entry in the list. In the first row, the row 0, I'm going to insert country sub-0, which is United States. In the next row, row 1, I'm going to insert country sub 1, which is Kenya. Okay. and then I'm going to print it out. Now, let me copy this text over, and then I'm going to have to edit this just a minute, but we'll run through it into PyCharm. Okay, let me fix my quotes. It looks like I actually did this. Okay. Let's see now if this works right. Okay. Oh, because it's a new. Here we go. It's a new Python console. So I need to start over with my metal table definition. Now I'll run my code. And now we can see that, in fact, I have inserted a new column. Here is the value of my metal table now. Row 0 now says 1, the string United States, 1411, 429. Row 1 has second place Kenya, 5 golds, 2 silvers, 4 bronzes, etc. The next row says the third place Jamaica, and so on. So this loop is how I inserted a new column into my 2D list, into my matrix. I inserted a column by using this for loop. Again, if I wanted to insert a row, it's just an insert or append. If it's a column, I've got to do it row by row by row, just because of the way Python works. This for loop just prints out one row at a time and makes the output a little easier to read, is all that does. If you print out the metal table, you can see the same thing. So you add a row by the standard append insert, just like you did with 1D. You add a column with this for loop, and you have to do this two-step process. One more change I have to make. Remember that rank is still column 0, but column 1 is no longer golds. Column 1 is now country because I inserted it. Column 2 is golds, column 3 is silver, etc. So what I would need to do now to make my old code work is I would have to update my constants. But yet that's another reason for adding constants, okay? Is if I updated my constants, now I can use my exact same code that I used before. I don't have to change anything. And let's run all this through our console with the updated goals and see if I can manage to do this right the first time. And you see that my code here ran perfectly with no changes. The only thing I did was change my constant. I changed my constant to reflect the fact that I moved a column over, and so the number of golds is no longer in column 1, it's now in column 2. No code change. This is why we use constants. Okay. Here's where we do this reading in a file, and here's where we get to project 1 and the relationship. All right, let's go to Python. What I did was I took that web page I showed you and I brought it down into my Mac, and I created a text file. I just copied and pasted the table as a text file. Why? Because remember, all the files we're reading in Python are text files, and we don't want all kinds of different things. So it's a fairly simple case. I've got 2 lines, and this is important. I've got 2 lines here that are not really important to my table. They're explanatory text that I copied from the original web page. The original web page had these 2 lines of text that got copied down. Now, I did fiddle around with it a little bit, and what I did, I'll give you a warning, is I deleted the blank spaces in the name. countries like United States, Great Britain and Northern Ireland, the Czech Republic, the People's Republic of China, etc., have blank spaces in the name. Because I'm going to use split, that's a hint, because I'm going to use split, I don't want blank spaces in my country name. So I actually went ahead and deleted blank spaces in the country names. Don't worry about how I did it. In program 1, you will not have to delete blank spaces in student's name. I've taken care of that. It's kind of a silly little trick, but you can do it. But so I have done this. But basically, if you copy that website I showed you where I got this medal table from and created a text file, and then you just delete the blank spaces, this is what you get. So this file is in the same directory as my coding file, and it is called medal_table.txt. And so I'm going to read it in and do something with it. Now, with, and if it helps if I spell it right, open medal_table.txt. Thank you, PyCharm, for telling me. For read, I'm just going to call that F. I'm going to say data equals f.read. Okay. Let's go ahead and do that and see what we get. Now, remember, the read statement reads in the entire file as a single string. So when I say, what's the value of data, you see that I have a long single string that has everything in the file. Okay. Remember also these \t things represent tabs. Python escapes or encodes a tab as a \t. A \n's a new line, a \t is a tab. Okay. So that's what that means in the string. So I read that in. Not exactly what I want. Let's think about doing this a different way. First of all, project 1 hint here. Remember, in my data file, I have 2 lines that I don't care about. I have 2 lines that are not part of my table. I want to read them and I want to throw them away. Well, we know how to read a line from a file. So let's simply say useless line equals f.readLine. And then the same thing. I'm not going to do anything with this. I'm just going to throw it away for now. Okay. And then I'm going to consume the rest of the file with a read statement. So let's run this. Okay. Now, when we look at what's the value of data, we see that we have the entire string with those first 2 lines read in and thrown away. When you are reading in the data files in project 1, this is exactly what you're going to do. You're going to have in each data file in project 1, 2 lines that are effectively useless to you. In the header of each file, you are going to have to read them and throw them away so that you can consume the rest of the file. How do you do that? You just read them in. You read in a line, you read in a line. Yeah, I could have written a loop that ran 2 times. I could have said for I in range 2, read line. But since it was only 2, I figured, 2 statements isn't too bad. I'll go ahead and write that one. That is how you would read in those 2 header lines and get rid of them. Now, you should be realizing, I think I said it Monday. If not, I apologize. I'm going to say it now. You should have an understanding whenever your Python program is going to read data from a file. You should have an understanding of what that file looks like. The term you hear is EDA. EDA stands for Exploratory Data Analysis, and I'm going to go add a slide to the end with these terms. EDA, it stands for Exploratory Data Analysis. What does it mean? For our purposes, it means look at your files and make sure you understand what data you're dealing with, what's important, what can be thrown away, what's an integer, what's a float, what's a Boolean, what's a string. Okay. If you're getting user input from the keyboard, man, not a big deal. If the user inputs the wrong thing, you can tell the user, sorry, that's a wrong thing, try again. You can't do that with a file. If you're expecting some rank, first place, and you get a long string that says, this is the medal table, you can't react. You can't do anything except, print out an error message and die a horrible screaming death. You don't want to do that. So you do EDA, you do exploratory data analysis, you look at your files and see if you understand what data you're dealing with. Okay. So when you do project 1, I've given you 4 data files. Look at your 4 data files and see what you're dealing with. Understand what's where. That will help you write code to deal with those data files. The other term you see a lot is ETL. Extract, transform, and load. Get the data you care about away from the rest. Transform the data you care about. You can only read it in as a string. You have to transform it to integer. From string, not sting. And load it. These are 2 important concepts when you're reading in data from files and doing analyses. Exploratory data analysis just means look at the files. Make sure you understand what's where. Make sure you know what you're dealing with so that your program doesn't trip over something and barf, because it will. ETL, extract, transform, and load. Anytime you're reading in data from a file, you want to extract the data you care about, ignore the rest. You want to transform, if necessary, into integers, for example, and load it, and then you can go. Let's go back to PyCharm. Okay, so going back to PyCharm, when we do this, we now have all of the data as a single string. Now what we need to do is split it into rows. Fortunately, because we've looked at our data file, we've done our EDA, we see that there is a new line. I am uncoordinated. All right. We see that there is a new line at the end of every country's data. So if I split this string on new lines, I will get a list of strings. So therefore, I'll go back to my code, and I will now say country list equals data dot split. Now, I don't want to split on all white space. I only want to split on new lines. I want to split on new lines because there's 1 record per line. Same thing gonna happen in project 1. There's going to be 1 student record per line. You're going to read the entire thing in as a string, and you're going to have to split it on new lines. When you do that, you see that you now have the following structure. You have a list. Each list has a line. Now we can split each row separately into a list. Right now, I just have a 1-dimensional list with a set of strings. A string, a string, a string. Okay. If I'm going to have a 2-dimensional list that represents this table, I'm going to have to split each of those rows, each of those strings into a row of data. So for I in range, length of country list, country list, let's see if this will work. Sub I equals country list sub I dot split. And now I am going to split on white space. By the way, this statement is why I had to remove the blank spaces from the country names. If I had United Space States, this split statement right here would have split United and States into two different elements, and that would have caused a problem. So that's why I had to delete the blank spaces. There are ways around it, but I didn't want to waste time on the ways around it. We'll see if this works or if I'm going to have to come up with a different code attempt. Okay, now let's look at country list. Now we can see we have a legitimate two-dimensional list. Here is row 1, and it consists of these columns. 1, United States, 7, 14, 5, 26. 2, Jamaica. By the way, this is not the 2019 list. For some reason, I just realized a little while ago that this is the 2014 results. The principle is the same thing. The numbers are slightly different. The principles are the same. Now, I have extracted the data I want, but I have not transformed it. Rank is a string. I probably don't care. Maybe I do. Maybe I need to transform it as an integer. These I clearly need to transform into integers, okay? So now what I'm going to have to do, and this is the last thing I'll show you with this one, is I'm going to have to write code that goes through each row and transform columns 0, 2, 3, 4, and 5 into integers. Okay. So how do I do that? Well, there's a bunch of different ways. The easiest thing is going to be the following. For I in range, length, country list. For each row, I could include this in the previous for loop. I'm not going to because I'm going to mark it off as a separate item. This is going to be transform strings to integers where appropriate. In each row, what I'm going to do is go through each column. Now, in this case, I've done my EDA. I happen to know that every row is the same length, so I can just pick any row. In this case, I'll pick row 1, the row 0, the first row. And I will go through each column. If J is not equal to 1, country list in row I in column J takes on its integer value. Okay. What's going on here? Because I looked at my data, I know that every value that is currently a string has to become an integer except column 1. Column 1 is a country name. It's meaningless to transfer a country name into an integer. I can't do that. So I'm going to go through and for every value in the matrix, every column in every row, unless I'm in column 1, I'm going to change the value. I'm going to transform it from a string into an integer. So let's make sure this works. Now let's look at country list. Now we can see I have the full two-dimensional table, a two-dimensional list in Python, my table, my matrix, my array, whatever you want to call it. My first row is the integer rank number 1, country United States, 7 golds, 14 silvers, 5 bronzes, 26 total. Second place, Jamaica, and so on. Okay. This is because I have to copy the 2013 results rather than 2019. Is the only reason the numbers and the ranks are different. But this is how I have gone through and read in a two-dimensional table from a file, and I now have it in my program and able to use. At that point, we're at 5 o'clock. We got 15 minutes left, and I'm going to transfer over to looking at Project 1 and explain why this is so important. I'll put out a message on Blackboard just to make sure everybody sees it. But if you go to the GitHub repository, you will see that I added a new subrepo called Fall 2020 Project 1. This should be all the files you need to do Project 1. It says section 61. It should say section 61 and 62. The 62 people do not get out free. This is for all of you, everybody in 60. What you see is that there is a PDF describing the project. There are 4 data files. All of these 4 things labeled .text are data files. There is a draft incomplete design, and there is a copy for your convenience of the coding standards, the rules of what you can use and what you can't use and how you have to comment and things like that. You can get it anyway from the course website or the Discord page, but I figured I'd put it right here just to make it real easy for you. Let's talk about what this project is. Okay. Come on and load for it. Okay. Again, you are going to submit a design. The design is going to be a text document. I've got an example of what goes in it. That is due 1 week from tonight. So you have 1 week and 7 hours to do the design. That is a text document that describes how you're going to write your code. The completed project, you have 12 days and 7 hours, Monday the 2nd of November, just before midnight, a week before the next exam, the night before the election, and this is a 100-point project. You cannot work with fellow students, obviously, TA, office hours, myself, what have you. Warning, you are doing a different project than the majors. Okay, the majors are writing a game. They are writing a version of the Monopoly game. I wanted to have something that was a bit more practical for people who are not necessarily taking computer science just to learn to play games and write games. For people who are taking computer science to learn to do useful things that will help them in their actual majors, I thought this might be a little bit more useful. So if you ask a TA, all the TAs have been told what our project is. All of them should be able to help. But if some TA asks you when you go for help at office hours, wait a minute, I don't understand. What are you doing this? Just remind them you're in this section. This is the assignment, and they should be able to help. Make sure you have the complete file header at the top of your file and everything is there. This should already be set up. If you finish this tonight, you should be able to submit it tonight. No problem. Again, this is different from the homeworks. You have to turn in a design document. We'll talk about what that is. The design document is intended to basically force you to deliberately think about how you're going to write your program rather than just coding as you go and document it at the end. Okay. It's going to be a single program. It's going to have a lot of functions. It's going to be bigger and more complex. And that's why we have you do it. We're going to give you a lot of the design. You have to follow it where you have options to do things differently your own way. We'll tell you, but we want you to get into practice of breaking things up into function using the design. To get the full credit, you have to run without any errors. And it's proj1.py. It'll be submitted on GL just as always. Just as with everything else, you create the proj1 directory. It'll have the design document and the text and the code in it. Mostly, we're trying to get you to do program design and functions, reading from and writing to files, using and manipulating lists. If you master these 3 skills right here, you're going to get a great score on Project 1. Write a program that computes descriptive statistics on CompSci course grades. We want to know how CompSci 201 students are doing. We want to look at their program grades. We want to look at their test grades. We want to figure out how they're doing and decide whether we're teaching this class appropriately. The grades are where they should be. We're making it too hard. Everybody's down in the 60s. We're making it too easy. Everybody gets in the 90s. Okay. So obviously this is fake data. It would be an invasion of student privacy if we use the actual real student test scores. So we've made up 4 data files representing, non-real comp sci students and assigned grades for them. And you're going to read each data file into a separate 2-dimensional list. Now, what did we just spend an hour talking about? Reading a data file into a 2-dimensional list. So that's why we covered that lecture right now and waited till tonight to issue the programming project, because this is exactly what you're going to do. Now, once you have the data files in, you're going to calculate means and medians for each class, and you're going to write the results out to a new data file. And so the end result of your project, when it runs correctly, is it produces a new file with results. We've given you these 4 input files as test data. You should get the right answers for those 4. Obviously, when we come to test your program to grade it, we've got some additional data files that are very similar but produce different results. So you can't, if you somehow fudge it and we don't catch you fudging it, so it only works with these 4 data files, it won't run with the other test data. So we'll catch you there. Don't worry about it. But I have faith in all of you. I think you're going to have it work on all data files. Okay, the files here are the names. Here's a description of what there are. Each file begins with 2 header lines that were inserted when I created the files. After that, there's 1 student record per line. Your program has to read each file into a separate 2D list. Each line of data contains student last name, which is a string, the student first name, which is a string, the student ID, which is a string. Student IDs are like UMBC IDs. They are strings. They are not numbers. And now you have 6 integers: the student's grade on project 1, project 2, and project 3, and the student's grade on test 1, test 2, test 3. Just as we did with the medal table that we just went over in class, you're going to have to read this thing into a file. You're going to have to split it into rows, and then you're going to have to walk through each row, and the relevant columns have to be transformed, ETL, transformed into integers. They will all be integers. I think at some point in the text I realized it said it might be a float. I don't think anything's a float. I think all test scores are integers. I don't think anybody got a 0.5 on it on the exam or anything. A note about the coding standards. I put them in this directory so you can find them. You got to have the file header comment we talked about. You got to have function header comments. You got to explain it. You should have constants instead of magic numbers. Basically, the coding standards are there to be used. Please follow them. Here's the design document. Okay, there is a file. We'll talk about it in a minute. It's in that same directory on GitHub. That is the start of a design document. It tells you how to write the rest of it. You have to have a file header showing what your program is going to do, list the constants you're going to define, then have function headers for each function you're going to use, and then have the pseudocode. You do not have to have Python code in this thing. This is a design. This is not code. This is not code version 1. This is all pseudocode. What are you going to do in your main program? Okay. You're getting the overview. You still have to create the headers, the pseudocode on your own. Okay. We'll look at this file next. It's not complete. Warning, you have to finish it. And this design has to be submitted next Wednesday. The reason for this is to get you thinking about the design and structure of your code, the design and structure of your program. Force you to think about it, get that done, and give you lots of time to then get the code going from there. Okay. You have to use the following functions that I'm giving you. You have to write. I should be honest. I'm not writing these functions for you. I'm giving you outlines for them. You have to write these functions. You have to write a function called mean that calculates the mean of a set of numeric values. You have to write a function median that calculates the arithmetic median of a set of values. You have to write a function standard deviation, STDEV. This is going to calculate the standard deviation of a set of numeric values. And you should be familiar enough with statistics to know how to calculate them. If not, let me know. It's a real quick thing on how to do it. Okay. You can use the square root value for math in standard deviation because a lot of things calculate the variance. The variance is the standard deviation squared. Take the square root. You can use the square root function. You don't have to say to the 1/2 power. That would be silly. In addition, you're going to read the files in a function called read file. Okay. Takes the file name as a string. You're going to read those first 2 lines and throw them away, just like we just did. Then you're going to read the rest of the thing, the rest of the file in as a string. Then you're going to have the function create lists. Create lists is what turns the strings in the files into these lists that you need of student records. Calc values is going to be the overall function that calls mean, median, and standard deviation. So calc values doesn't actually do the calculation. It calls the functions that do it for you. So design program, big function, calculate values, little subfunctions, helper functions, calculate mean, calculate median, calculate standard deviation. Okay. And write file, this is when you create your output. So you must have, at a minimum, these functions in your program. You can have additional functions as needed per your choice. These functions have to be there. And your main program is described here, and then it is submitted. So that is the assignment. The design that we give you, that is, as I said, has to be completely filled out by and submitted by next Wednesday night. Standard submission on GL, by the way. So if you have any questions, let me know. But you submit the design the same way you submit the other programs on GL. Here is the file. Replace design1.py with your. I'm sorry. This is actually the correct name. This should be design1.text, not py. That's a typo on my part. Your name goes here. Your lab section, your email. Description of the program, assumptions, fill this out basically. Any constants you're going to define them here. And now for each of those functions that I talked about, you have a short description of what that function does. So here's an example. This is what the description of mean looks like. This is good enough for mean. This is what the definition of median looks like. This is good enough for median. Follow this pattern and write similar function comments for every other function. I've given you mean and I've given you median. Do the same thing with the other functions. This is a design document. And here's the pseudocode for your main program. Read in a file, break the string into components, call function to calculate, blah, blah, blah. Write your pseudocode. So this document is going to be filled out. You're going to fill in your header comment with the appropriate information. You're going to develop. You're going to identify any constants you're going to use. You're going to write function descriptions for all the other functions that I haven't given you. I've given you the 2, mean and median. And you're going to finish the pseudocode for your main program. And then you're going to submit that by next Wednesday. That lays down a baseline. That shows that you understand how this program is going to be broken down, how this program is going to be coded, how this program is going to be built. You are going to break it into functions. You are going to write a function. You're going to test a function. And then you're going to have the whole thing working. This is actually in many ways easier, I think, my opinion only. I'm willing to be told I'm wrong, but my opinion, this program is easier than some of the homeworks you've done. It's just longer. It's your first time at dealing with probably, I'm guessing, 150 to 200 lines of code. If you're much more than 200 lines of code, not counting comments, you're probably doing something wrong. But you should be somewhere 100, 150, 200 lines of Python, not counting comments in this. So it's longer than what you've been doing in homework. At any rate, that's the design document. The data files look like this. So the fall 2021 students are a bunch of Nobel Prize winning physicists and chemists. These are the first 2 lines I told you about that are useless. You'll read them and throw them away. Here is your actual student data. Last name, first name, student ID, project 1 grade, project 2 grade, project 3 grade, test 1 grade, test 2 grade, test 3 grade. Okay. It doesn't come out as a nice, pretty table because the people's names are different lengths, so things get separated differently. This is what happens when you use a plain text file. Later projects won't use plain text files exactly this type. They'll be a little different. Okay, this is what each file will look like. It turns out that the students in fall 2021 are these Nobel Prize winners. The students next spring in spring 2021 happen to be the members of the U.S. women's soccer team. I think I created this last year when they were winning the World Cup. The spring 2022 students are a bunch of Games of Thrones characters. Yes, I am a geek and proud of it. And the other, where's my other? The fall 2020, this semester students, congratulations. You are all characters from the Big Bang Theory. Yes, I am a geek and proud of it. Again, I've tried to make it, I used hyphen and names, so there is no, Amy Farrah Fowler actually did not have a hyphen between Amy and Farrah. There were 2 words, but that would cause you problems when you split on blank spaces, so I put hyphens in that. I put hyphens in Rostenkowski-Wolowitz. You should not have any problems with any of those. But those are Big Bang Theory characters. So like I said, if I used real students, I'd had an invasion of privacy problem. So I used fake students. And that's what you have with these 4 things. So that is project 1. And I wanted to spend at least 15 minutes talking about it. And I actually was able to. So I wanted to cover the 2-dimensional lists and how to read it in from a file and how to manipulate them because, as you see, that's what you're going to be doing in Project 1. We do it exactly, we get the data ready exactly the same way we did in lecture today, right? We read in the file, we read those 2 lines and just throw them away because they're useless lines. We don't need them. Then we read the rest of the file in a single string with a read statement. Then we break the string up into rows based on new lines. Based on the \n new line character splits it into rows. Then we have to split each row into columns. Then we have to go through each row and each column and change the appropriate values into integers so we can do math. You cannot calculate the mean of a string. It doesn't work. So you're going to have to do that transform, extract, get rid of the 2 extra layers. Transform, change it into integers. Load, now you've got it in your program to calculate the mean, the median, standard deviation. Exploratory data analysis, you've looked at these 4 files, you see what they look like, you see you have 2 lines to throw away, you see everything else looks appropriate, and you're good to go. Okay, so that was what I wanted to cover the lecture because it walks through what you need to do for these 2 things. Now, I believe that everything you need to do Project 1 has already been covered in class. If not, I will be happy to go over it again. I plan on spending a lot more time next Monday on 2D lists because I realized I gave it a little bit of a short shrift with this. I will also be happy to cover more file I/O on Monday, and we'll get into program design, and then we'll move into finally actually covering dictionaries. Okay, with that, I apologize, but I have kept you already too long. If you have any questions, the homework's due tonight. You should be able to submit it. If you have any questions, be sure to let me know. I will got to run off to something at this instant, but I'll be back in a little while. And I'm available on Discord or email or whatever, and we'll get together. So thank you all for attending. I owe you about 4 minutes sometime, and I will talk to you later. Thank you much.